we are going to do long division with polynomials.
Oh my God.
But I think it's important that you guys look at long division the way you did it in elementary school. If you were asked to do this problem, do you guys remember what the name of the 12 was? Divisor, dividend, quotient? 12 is called the divisor, 25,462 is the dividend. And when we find the answer, that's gonna be your quotient. Sometimes there's gonna be a remainder and sometimes it goes into it evenly. If this number goes into 25,462 evenly, we say that this is a factor of 25,462. If there's any kind of remainder, then it's not a factor. Okay, we can still perform long division, we just have a remainder. So now, do you remember how to do long division?
Nope.
Ooh, you gotta remember this. How many times does 12 go into 2?
0.
Well, it doesn't. So we extend this 2 to 25. How many times does 12 go into 25?
Twice with one left over.
Twice, with one left over. What number do you put here?
24.
24. How did you get 24?
Because that's something times
You
12.
multiply. Now, what do you do with these two numbers?
You subtract them.
Subtract. Remember that. You subtract. What do you get here?
1.
What do you do next?
We bring the 4 down.
You bring down just one number, a 4. Now what do you do?
See how many times 12 goes into 14?
Well, how many times does 12 go into 14?
Once.
Once. And what do you do with that? Multiply. Then what do you do?
You subtract.
Subtract. Remember that. Subtract, you get a 2. And then you get 26. You bring down the 6. Then what do you do? 2. You get 24. Then what do you do? Subtract. Remember that. 2. Bring down the 2. How many times does 12 go into 22?
Once.
Once. That would be 12. What's left? 10. The remainder is 10. So we say, a lot of times we'll write R10. What you could do is write 2,121 with a remainder of 10 over 12. Okay, that's how you're going to write it in this class. Now, how do we do long division with polynomials? So if I ask you to divide this x plus 2 is like the 12, that's your divisor. You're going to put that outside the box. And inside the box, which is the dividend, is x cubed minus 2x squared minus 5x plus 6. The same process is going to occur. We want to try and get rid of this x cubed. So what times x will give you x cubed? X times x squared gives you x cubed. So what you're going to do is multiply this times both of these. You get x cubed plus 2x squared. Now remember what I said to remember? What do you do with these two? You will subtract them. This is the trickiest part, right here. You'll end up getting rid of the x cubes, because do you agree that x cubed minus x cubed is no x cubed? It's this part where a lot of people mess up, and you don't have any room to mess up here, because if you mess this up, the rest of your answer is going to be wrong. And that's where, after doing this for many years, this is where I see the big error. So try to fix this right here. How many of you think you know what this number is right here when you subtract it? Half of you guys think it's 0. Anyone know what it is? What is it? Negative 4x squared is the correct answer. Because you have to this is going to be a negative. You are subtracting this. So negative 2x squared minus 2x squared is negative 4x squared. Okay? Now what you're going to do is, like you did in the other problem that we did, you're going to bring something down. What do you bring down? What's next in line, which is negative 5x. Now we want to get something times x. I want it to be a negative 4x squared. And that would be negative 4x. Because negative 4x times x is negative 4x squared. And then negative 4x times 2 is negative 8x. So now what did I say you're going to do here? You're going to subtract these. So these will cancel, but what do you have here? 3 what? And that is the correct answer. You're going to bring down the next thing in line, which is your 6. Now what times x is 3x? We need a 3.
3.
So you're gonna multiply 3 times x and 2, you get 3x plus 6. And when you subtract these, what do you get? A 0. So in other words, x plus 2 goes into x cubed minus 2x squared minus 5x plus 6 evenly. There is no remainder. Do you get this?
Mm-hmm.
If you wanted to check to see if this was the correct answer, this is the quotient, by the way, you would multiply these two together like you would do when you checked it long division. You would multiply these two by foiling, or not foiling, distributing, and you'll get the original, the x cubed minus 2x squared minus 5x plus 6. So
is
let's
that
do
like
another one.
simplified?
Say it again.
So is that like simplified? Like is that like the simplified form of like x cubed minus 2x squared minus 5x plus 6?
This is factored, yes, this would be factored. This times this it's factored.
Alright.
Now, you could even factor this further, because we know what the factors of this are. This would be x minus 1 times x minus 3. So what we're getting you to do is to take this and break it down. So this could factor the x squared, the quotient, which is what you got here. Do you realize that this is factored even more? And that's what you get. X minus 3, x minus 1. Let's do another one. Now you can only factor it more if there's no remainder. How do you do this one? We're going to do long division again. We're going to take 2x plus 3 and we're going to divide it squared. Now if in the dividend, this is the dividend, if there's any missing terms, you're going to put a 0. Okay, so now let's do this problem. I need a 6x cubed. So 2x times what is going to give me 6x cubed?
3x squared.
Good, 3x squared. Now you're going to take 3x squared and multiply it by both of these. You get 6x cubed and then plus 9x squared. Now this is the part where I get a lot of errors. I need to subtract these two. Notice how I put parentheses around them? What do you get when you do x squared minus 9x squared? Good, negative 8x squared. Bring down the negative 2x. What times 2x will give me negative 8x squared? Negative 4x. Negative 4x times both of these is negative 8x squared, and then minus 12x. What do you get when you subtract these two? You get 10x, good job. And then plus 8, bring down 18. So 2x times what is 10x, which is 5. 5 times 2x is 10x, and then plus 15. Did this go into this evenly? Why not? Because I have a remainder of 3. There's some left over. So how will you write this answer? You will write 3, the answer was 3x squared minus 4x plus 5 with the remainder, add, or if this is a negative you would write minus, 3 over the divisor 2x plus 3. Easy? Okay, one more. This one we're going to have x plus 3 outside. Now underneath we've got some issues. We have some holes. So you're going to write x cubed. We don't have x squared. We don't have x, but we do have 48. Now the reason why you need to put these zeros here is because when you multiply, you're going to write x squared right here, because x squared times x is x cubed. If you don't have this here, when you multiply x squared times 3, you would normally have a 48 here and you'll be messed up. You won't know what to do with it. This gives you a placeholder so that way when you subtract, these are lined up. So it's very important. If you do one of these problems and go, oh, I don't know, I'm lost. I have an x squared and a number here. It's because you didn't put a 0 somewhere, and you'll see it, you'll know what I'm talking about. So, everyone understand why I put x squared here? X squared times x is x cubed, and x squared times 3 is 3x squared. Now, when you subtract these, what do you have right here? Good, negative 3x squared. Now you bring something down. You're actually bringing 0x down. Okay?
Miss, can you explain what you just did?
Where?
Like, why
This.
yeah.
Okay, this is your dividend right here, x cubed plus 48. But see how it jumped from x cubed to a number? There is no x squared. There is no x to the first power, and I have a 48
So you
here.
have to have whatever's like between like the
Yeah,
outer numbers?
these are some holes here.
Okay.
So you want to put placeholders, okay?
Mhm.
You want to put placeholders here. So now your job is to get rid of x cubed. So you're going to have an x squared here. And x squared times x is x cubed, and x squared times 3 is 3x squared. So when you subtract these cancel. 0x squared minus 3x squared is negative 3x squared. And you're going to bring down x. Megan?
I was gonna ask how you got the x squared, but I think I
The x, what x squared? This, because this times this is x cubed.
did.
You wanna get this match right here. You've got an x, what am I missing to get x cubed? You need x squared.
For the x squared, how do you put 3x squared? Did you do 3 times 0 or 3
I did
plus
this
3?
times this. This times this is this times
Okay.
this is that. Now subtract these. 0 minus 3 is 3x, negative 3x squared. Bring this down. Now, I want to get rid of negative 3x squared, so I need a negative 3x. Because negative 3x times x is negative 3x squared, and negative 3x times 3 is negative 9x. Now, when I subtract these, what do you get? You get what? I heard it. 9x, good job. Now you're gonna bring down 48. And now I'm gonna put a 9 here. 9 times x is 9x. And 9 times 3 is 27. What do I do with these two? Subtract them. So what do you get? 21. What's the remainder? 21. So the answer to this problem is x squared minus 3x plus 9 with a remainder of 21 over x plus 3. Okay? Now, I have a shortcut on some of these. The shortcut is called synthetic division. If and only if the divisor, which is the divisor? Which of these two is the divisor?
The one
X
right?
plus
X
2.
plus 2, the 2x plus 3, and the x plus 3. If the divisor has a degree of 1 and a leading coefficient of 1, you have to have a 1 and a 1. It has to be 1x to the first power. If it is a 1x to the first power, you can do the shortcut. So on these three that we just did, you can't do the shortcut on this one because of the 2 here. That messes you up. But you can perform the shortcut on these two right here. How do you do it? And you're gonna like it much better. Synthetic division, what you do, you take the divisor and you give me the opposite of this 2. What's the opposite of 2? Negative 2. You're gonna put, and this is how you do synthetic division. And I have the problem right here for you, number 4. We're gonna perform synthetic division with that same first problem we did. You will take the opposite of this number, this constant, which is negative 2, put it outside of a box. Inside the box, you are going to list in order, in standard form, all of the coefficients, least to greatest. And if there's any holes, you put a 0. So what's the coefficient of x cubed? 1. What's the coefficient of x squared? What's the coefficient of x? And what's the coefficient? That's gonna be your constant right there. This is how synthetic division, and it's gonna take you a couple tries to master it. So, what you do is you always bring down this first term. You will multiply these two together. So you bring down the first term, you perform multiplication with these two, and you put it here, and then you add. So you get -4. Then you multiply. You get 8, and then you add. And then you multiply, and you add. Now I want you to stare at these 4 numbers here, and tell me in the problem that we did, the first one, where do you see a 1? Where do you see a -4? Where do you see a 3? And where do you see a 0? So here, a 1, a -4, a 3, and a 0. A 1, a -4, a 3, and a 0. Where do you see it? 1, a -4, a 3, and a 0. And that's exactly what you'll get. So, what are these bottom numbers? These are the coefficients. You're gonna go 1 degree less than that. So it's gonna be 1x squared. You started with a 3, you're gonna have a squared now. Minus, and you go in decreasing order, -4x plus 3. This will be your remainder. So let's check out number 3 that we did. Let's do synthetic division with this one. What you would do is put a -3 outside the box. Inside the box is gonna be a 1. Anyone know what number goes next?
0.
0. Another 0 and a 48. You bring down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Guess what we have here? 1x squared minus 3x plus 9 with a remainder of 21. How about that? Okay, let's try. Okay, wait, sorry.
Where'd you get the x squared from?
You go 1 degree less than this.
Okay.
That's gonna be the answer. It's always 1 degree less than that. Do you see it?
Mm-hmm.
Plus 9 and the remainder is 21.
Alright.
Now, if this was a 0 remainder, you would try to factor this some more. You could. So let's try number 5 with synthetic division. Tell me what number, can we do synthetic division?
Yeah.
Yeah. The degree's 1, leading coefficient's 1. What number goes outside the box?
-1.
Good job, -1. What goes inside the box?
1,
A 1,
0,
0,
3,
3, and 4. So how do you do synthetic division? You bring down the 1, and what do you do with these two? Multiply them. Add, multiply, add, multiply, 0 remainder. So, did this go into it evenly? Yes. What's the answer?
x squared minus
1x squared.
1x plus 4.
Got it. So, you can only use synthetic division when the leading coefficient is what? Positive 1. I think I spelled coefficient wrong.
Yeah, I'm trying to
Yeah.
figure out this one.
Yeah.
2 F's. Is it 2 F's? Yes. And what else? Your degree of the divisor is a 1. So look for the divisor. And if it's a 1 and a 1 for the leading coefficient, then always look to do synthetic division. Don't you think synthetic's easier than long? Okay, now, check this out. Number 6. If I gave you this problem, 2x cubed plus 7x squared plus 2x plus 1. And I asked you to divide x minus 5. So if I gave you this problem right here, x minus 5, how would you do synthetic division? What would you do?
Positive 5 on the outside.
You would put a 5. The opposite of this number would go outside, right? And let's do it, since we're all good at synthetic division now. We're gonna put a 2, a 7, a 2, and a 1. And I want you to do this with me. You're gonna end up with a big number at the end. So bring down the 2. 10, 17. Right? Help me out, 87. I think this is 435. You get 436 here. So, if you were to do this division, 436 is your what? Remainder. So does x minus 5 go into this evenly? No, it
No.
does not. There's a remainder. Now there's another way to find the remainder, and it's called this find p of 5. So you could, if you wanted to see if something goes into something, there's another alternative method. It's called the remainder theorem. If you take the opposite of this number, so 5, and you would evaluate this function, so in other words, what is p of 5? You would plug in a 5 where you see an x. I want you to do this. 2x to the third power plus 7x squared plus 2x plus 1. Now what I've done is I've taken this function, I've put a 5 in. So you take the opposite of this and you plug that number in here. Guess what you're going to get? You're going to get 436. If you were to cube 5, you get 125. And I will do it here for you and show you on the calculator. So 2 times 5 to the third power plus 7 times 5 squared plus, I can do 2 times 5 in my head, and then plus 1, and you get 436. So you have 2 ways to find the remainder. Or asking you, now someone in my last class said, why do we need to know the remainder? Because when you start breaking these polynomials up, you want to see if it, you want to look for a 0 remainder, because if it does, then it goes into it evenly. It'll help you find, we're going to start graphing these. So you want it, you're going to have to look for how to break it up. Next, try another one. So this problem would say, take 3x cubed minus 4x plus 3, and I want you to divide it by x plus 2. So what would we do? We would put a -2 outside of the box, and we would do a, see if you can tell me what to write here. 3, 0,
Oh, okay.
-4, and 3. So tell me what you get. Everyone do it. So, does it go into it evenly? No. The remainder is what?
-13.
How would you write the answer? Just for fun now, how would we write it?
3x
X squared
minus 6x.
plus 8 with a remainder of 13 over, and then we would write x plus 2. That's how you'd write the answer. Now let's prove this remainder theorem works by evaluating this function for p of -2. We would put -2 here. So 3 times -2 cubed minus 4 times -2 plus 3. What is -2 cubed? It's -8. -8 times 3 is -24. This is going to give you 8. Well, 8 and 3 is 11. What's -24 and 11? -13. Does anyone else add like I do? Take the positives and add them, and then subtract. Questions on that? Anybody? So these last two questions are asking you to tell me whether or not, so determine yes or no, is this a factor of this? How are you gonna do it?
Substitution.
I would do synthetic. I would do synthetic. What number goes outside the box? -3. And what numbers are you gonna put inside? 3, 10, -1, and -12. Tell me yes or no. And if not, what is the remainder? What'd you get? I got 0 also, yes.
Can you done the substitution?
Yeah, you could do substitution. It doesn't tell you. You could have done 3 times -3 cubed plus 10 times -3 squared minus -3 and then minus 12. I'll tell you where most people make errors is doing substitution. Okay,
Would it be positive 3 on the inside?
where?
For the x? Because I thought you take the.
You take the opposite of
Okay.
this and you plug it in. And you'll get 0. So the question was, is x plus 3 a factor? Yes, it is, for that one. Is it yes or no for the next one? You would put -2 outside, and you have 3, 10, -1, and -12. So bring down the 3, multiply, add, multiply, add, and I already know it's gonna be no. Your remainder is 6. Questions?
Oh, sweet, this is it? Oh, this is bad. Not happy.
Okay. Let's do as many as we can, and the rest will be homework.
Moving up and moving.
You ever get done in like 4 minutes?
We get done in 4 minutes?